Have another problem here, but this time with a geometric sequence. So I'm being given u3 and u7, and I've got to find u to the power of n. Well, I need u1 and I need r. So the easiest thing to find is r to begin with. How do I find that? Well, un is equal to u1 times r to the n minus 1. What it also means, that's what I'm trying to find. I'm going to try and find r and u1 is my final answer. But what it also means, I can get u7, which is 12, by taking u3 and timesing it by r 4 times. So u3 times r will give me u4, times it by r again, it will give me u5, etc., etc. Now let's just fill in u3 as 3/4. Let's multiply each side by 4 and divide by 3. So something to the power of 4 equals 16. R equals 2. Actually, r could also be negative 2 in this case, but I'm just going to take r as being 2, just for simple sake here. So to get u1, what I would have to do is just divide u3 by 2. So I just take 3/4 and divide it by 2, which gives me 3/8. And that's the previous term. And then divide it by 2 again to get 3/16. Just double checking out on my calculator. So now I'm ready to write out this u to the power of n term, which is going to give me the first term, 3/16, times r, which is 2, to the power of n minus 1. That's my general term. Now for b, what term is equal to 3072? So let's put b up here, and let's put 3072 in here. And it's 3/16. Let's move all this over one part across like this. And we can just move this across. Times 2 to the n minus 1. So a bit of algebra again. 3072, times that by 16, divide it by 3, and we have 16384 equals 2 to the n minus 1. If I have a missing component or as an exponential, I take a log of both sides. So I'm going to take the natural log of this. I'm going to use my calculator, obviously. And I've got n minus 1 times the natural log of 2. So I'm taking a log of 16384, dividing it by a natural log of 2, and I have n minus 1 equal to 14. Then n must be 15.